My name is Alyssa, and today we are going to be doing a chemistry experiment. Ooh. So we're going to go over some terms and definitions as well. And the question we're going to be answering today is, why is the Statue of Liberty green? Interesting. We're going to find out on why a completely copper statue went from being a bright, dull brown copper color to what is now the traditional color of green. So I have an experiment we're going to do with some copper pennies. So let's do some background information and we're going to jump into our experiment. Ready? Here we go. So before we jump into the experiment, let's get some background information on what the Statue of Liberty actually is and then why all of a sudden it decided to change colors. So some facts about the Statue of Liberty is that the Statue of Liberty was designed by a French architect and sculptor named Frederic Auguste Bartholdi. The statue was actually built in France in 1884. It was then disassembled into 350 pieces and taken to the US aboard the Isère, the French fatigue ship, in 1885. The pedestal that the Statue of Liberty actually sits on was designed by an American architect, Richard Morris Hunt. And then once the French were bringing over the sculpture in 350 pieces, it took them 4 months to reassemble the statue on the pedestal. Now, the statue was gifted to the U.S. from France to commemorate the centennial of the American Declaration of Independence. It also is a symbol that expresses the friendship between France and the U.S. during the American Revolution. The Statue of Liberty was dedicated on October 28, 1886. Construction for the Statue of Liberty actually started way back in September of 1875, and it was declared a national monument in 1924. Now, when it was first built and developed, it was the highest iron structure in 1886. The official name of the Statue of Liberty is Liberty Enlightening the World, and the statue actually stands for liberty, and its torch lights the path to freedom and liberty. The statue was built on Liberty Island. At the beginning, when it was first built, it was Bedloe Island, which is actually located in the New York City harbor. The Statue of Liberty was made with an iron frame with copper sheets over the iron frame. Now, the thickness of the external copper sheets is 332 of an inch, which is almost as thick as 2 pennies placed together. So not really thick if you think about it and put 2 pennies next to each other. The amount of copper actually used for the statue is 62,000 pounds and is worth about $200,000 today. And if we were just talking about the general scrap metal in the entire Statue of Liberty, it would be about $150 million. That's wild. The Statue of Liberty actually stands 305 feet and 1 inch tall, about 93 meters, and weighs 225 tons, or 450,000 pounds. A fun fact about the Statue of Liberty is that its shoe size would actually be 879. Really big feet. The statue faces the southeast, so it can act as a welcoming symbol for ships entering the harbor. And actually, towards the beginning of the Statue of Liberty's life, it actually functioned as a lighthouse for 16 years. And there are also many famous replicas of the Statue of Liberty. The most famous would have to be the Statue of Liberty in France. It's about a quarter of the size of the original Statue of Liberty and stands only at 11.5 meters tall and weighs only about 14 tons. Now, you're probably thinking, wait, if this was made of copper and copper pennies are brown, then why is it green? So, to explain our green color, we are going to start off saying that it was a dull brown to start with because it was made out of copper. Over the next 30 years, so it started showing this green color in 1906, was due to the effect of weather on the copper. Now, copper reacts with the air to form a patina or verdigris. Verdigris is a green or bluish patina formed on copper, brass, or bronze surfaces exposed to the atmosphere for long periods of time, consisting principally of basic copper sulfate. The verdigris layer protects the underlying metal from corrosion and degradation. which is why copper, bronze, and brass sculptures are so durable and why there's many still standing today. The Statue of Liberty is actually its own special color because of its unique environmental conditions. It's not just a simple reaction between copper and oxygen that produces the green oxide. So copper oxides continue to react to make copper carbonates, copper sulfide, and copper sulfate. There are three main compounds that form the blue-green patina, and I've listed those three right down under that statement. So you're probably wondering how those crazy combinations of letters and numbers came to be. Well, going into a little bit more scientific explanation, initially the copper from the statue reacts with oxygen from the air in an oxidation reduction or redox reaction, where essentially the copper is donating electrons to oxygen, which oxidizes the copper and reduces the oxygen. Then that copper oxide continues to react with the oxygen and then forming copper oxide. When the Statue of Liberty was initially built, the air contained a lot of sulfur from the air pollution produced by burning coal. The copper sulfate reacted with carbon dioxide from the air and then hydroxide ions from water vapor to form the three different compounds which are listed beneath. So that's how they ended up getting those compounds that form the blue-green patina. Now, the speed at which the patina develops, in this case, it took about 20 years for the green color to start changing from brown, that dull brown copper color, to the green we see it today. And the color actually depends on the humidity and air pollution, not just the presence of oxygen and carbon dioxide in the air. Now, patina develops and evolves over time. So since all of the copper in the statue is still the original metal, the Verdigris has been developing for over 130 years. So, with what we know, how the sulfur, the carbon dioxide, water, the environment of the Statue of Liberty, this means the color could keep changing and could be even getting deeper green or a wider variety of green. So, this is a little bit more of a chemistry explanation on why it's changing green. We're going to jump into our experiment where we are actually going to be able to see the effects of this green and patina on regular pennies we have in our house. For our penny experiment are going to be copper pennies. You can have a couple of them. I'm probably going to have like 8 to 10 so I can see the different effects on which pennies work better with the vinegar and the salt. You'll need some vinegar or white vinegar, salt, maybe a small bowl and dish, measuring spoon so we can measure out our vinegar and salt, and some extra paper towels so we can pull it out of the bowl and see the effects from a paper towel. Hey everyone, so I have collected all of the materials and supplies we need for our copper penny experiment. We're going to need some salt. I have some white kitchen vinegar, a small measuring cup, a teaspoon, and I have an assortment of pennies that are both a combination of shiny and some old dull ones as well to see which effects are better. Now to start off, we are going to put a teaspoon of salt into our cup. I also have a couple extra pieces of paper towel to help have the pennies sit on something clean, and then also something I can put salt and shake over without making a giant mess. Alright, so I'm going to add that in. I'm now going to add my vinegar. And I'm just using a small little cup bowl to mix my vinegar and my salt together. You feel free to use a cup, a bowl, whatever makes sense for you and whatever is easily accessible. Alright. And once we have added our salt and our vinegar together, we are going to mix it up. Now move those off to the side. We're going to want to make sure that everything is mixed really, really well. As we're mixing, we're going to try and dissolve the salt. So it might take a couple minutes for all of the salt to truly dissolve into the vinegar. So we'll just keep stirring. And as I always say, make sure you double check with mom and dad before you start grabbing materials and start jumping into the experiment. Or better yet, have mom and dad join us while we're doing the experiment. Now that we have mixed all of this up, we are going to start off by just taking one of our kind of super dirty, really dull pennies, and we're just going to hold it in for like 5-10 seconds, kind of see what happens to the effects. Alright, so after holding it for a little longer than 5-10 seconds, I'll hold it up to the screen to see if you guys can see. You'll definitely be able to see it in when you're at home. So as you can see, it looks like half of our penny looks shiny and the other half looks dull. So it almost looks like the solution actually cleaned it. So we're going to actually drop more of these in. We'll leave that one out to see if we can see it compare. So I'm going to drop in about maybe 5 pennies. And we're going to let them sit for about 5-10 minutes to see what the effects are, and then have them air dry and see what happens. One of the reasons the copper coins dull in the first place is because copper reacts to the oxygen in the air, and they form a layer of copper oxide, which is the dull greenish color we end up seeing on pennies. So that's how we have like super shiny pennies when they first come home, and then over time we'll notice those like dark gray pennies that don't even look nice anymore. So we're going to wait and see what happens to these pennies as they're sitting in this solution, and then we'll pull them out and see what happens. Alright guys, so I have let these sit probably a little longer than 10 minutes, so I'm actually going to fish my pennies out of my solution. Try and get some of the vinegar out, and then I'm going to put them on my paper towel. So just from pulling out the first couple I have right here, what I'm noticing is that the pennies I dropped in were definitely more of a darker color. They're all now look like brand new shiny, just like they had just come home from the mill. And now we're going to let and see what the air does to them. See if it starts changing the effects of our pennies. So with this experiment, it's actually longer to let them sit out in the air. So sometimes you can see greater effects waiting an hour to even 24 hours to even 48 hours. This one we're going to probably wait, I'd say maybe 5 to 15 minutes to start seeing if we start seeing the chemical reaction, if we start seeing what our shiny pennies looking brand new, and to see if they're going to start going back to that dullish gray color because of the elements. Now, letting it be exposed to the air again, it's reapplying that oxygen, which is going to react with the copper to create that copper oxide green layer, which forms that green bluish hint, like the Statue of Liberty. Now, we might not be able to see it right on this video, but definitely hold it out and see if the results change. Maybe come back in an hour after taking some time playing outside and seeing the different results. And another cool fact is when we're actually mixing the salt and the vinegar, we're forming a sodium acetate and hydrogen chloride. The hydrogen chloride is a very strong acid, and it actually works really well in cleaning the copper, which is how it comes out looking shiny and brand new, because it's removing that oxide. Now that we are reapplying oxygen and reapplying elements to the copper again, it's going to start forming that copper oxide and then forming that gray, dullish green color hue. So I'm going to let you hold these out. Maybe I'll do another video where we can look at the results and see if my pennies turned green after waiting a while. So definitely get back to me after your experiment. Were you able to see the pennies change color? Were your results the same? Were you able to clean up some of your pennies? Let me know in the comments. I'd love to hear your feedback, and if you want to do more videos like this, please let me know. Have a great afternoon, and I'll see you soon. Bye, guys.